I'm sure this one you can guess it will be an equal diameter. Same thing, we have internal and we have external. For each of these, the methods are kind of different. So just for line tangents, we have 4 methods that we need to recall. Well, I'm not counting that one we did. That should be just some basics that you need to know. So we'll start with our tangents that are line tangents having equal diameter. I'll do a brief overview so that you can understand, and then we'll draw something with distances. So if we have two circles of the same diameter, they might be positioned on the same, but I always like positioning them on different places. You can say that I'll put dimensions here, and that's what we'll draw. Our tangent can be external like that, or it can be internal, touching like that. We'll start with the external one. It's very easy. Like I said, most of the people will be tempted to just draw a line. This one is the easiest to draw because if these two circles are having the same diameter, it's just like you're drawing a parallel line to the circles. So what we do is, again, we start with joining our centers. You get used to this procedure. We'll be talking about the centers a lot. You join your centers, and then to find the point of tangency, you just need to construct an angle that is 90 degrees to this line that we've drawn in blue. Usually you can just use your construction of angles. At least you should know how to construct a 90 degrees angle. Do you? You don't? Okay, we'll cover a very simple way. In angles, I like the concept of bisecting. If I get 180 and divide by 2, I'm going to have 90 degrees. This is very helpful when we're working with angles. And if you can see, this line already here is a line that is at 180 degrees. So if I extend that side and this side and that side, I can draw an arc standing at this point and then bisect this angle. To bisect an angle, the procedure is very easy. Let me show you with a different angle so that it doesn't look like I'm doing nothing there. If this angle, let's say, is 30 degrees, if I want to bisect it, I'll stand at the point where the angle is being formed. I draw an arc, and then with the same radius, I'll stand at this point here, you can say this is point 1, and this is point 2. With the same radius, I'll strike an arc like that and an arc like that. This point that I now have is going to enable me to have a 15 degrees here and a 15 there. If we do the same on the 180, it's a bit kind of weird because we haven't drawn any two lines. This same straight line is the 180. So we just choose a point where we want our angle to come from. That center, we draw an arc. With this same radius, you could, but usually when we're working with the 180, you get the distance from this point 1 here to point 2, and then draw an arc like that, and another one like that. This point here will give you your 90. When we're working with tangents, you don't have to come and construct another 90 here. That will be wasting your time. These points of tangency can be transferred. So if I get the point of tangency here, I know that this is going to touch at the top. If this is the same straight line, you can just slide this line on this other point like that, and it will show me the point of tangency. Which means if we're given a circle here, let's say this is 50 radius, automatically this gives us 50. If these are very far apart, let's say 150 in our x, it can be shown like this. Remember, these are basic signs. They might be boring sometimes, but when they are put in questions, most students might be surprised. Let's give this a very simple distance. Let's say we have 50. Given that information, we can draw that tangent. So we'll start just like we earlier started. We'll start with our circles. Before we draw the circle, we need our center line. That's our center for the first circle. Okay. It looks like it will go. You are weak up of maybe from here to somewhere there on top. Just support. Is the 50 too big for a paper? Okay. So if it is too big, then I'll introduce you to something that's interesting. So if it's too big for a paper today, we're going to say, let's use a scale. One to two. Now, what does that scale mean? If it confuses you ever in drawing, just convert this to a fraction. Eh? What fraction does it give us? Half. Eh? If the fraction is less than 1, it means what you're going to be drawing is going to get smaller than the distances you have there. If they say 2 to 1, the fraction is 2, right? It's larger than 1, which means your drawing or the distances that have been given are going to be smaller. Or in other terms, the drawing is going to be bigger. If you want to really understand what happens here, the first number shows you what is on your drawing. I like the acronym DO. Right. So this is your drawing, and then this is the actual object, the dimensions that you've been given. So if on your drawing you have 1 millimeter, then the object is supposed to have 2 millimeters, right? So in actual sense, we are getting the object and reducing it in our drawing. Don't know if that makes sense. Whichever you prefer. If you want, you can just know that. If it's less than 1, you get the bigger number, and then you'll be dividing by these distances. Right? So if you convert this to a fraction, it's 1 over 2. So you get half and multiply by all these. If this scale was 2 to 1, what's the fraction? 2. So you get this 2 and you multiply. But if you want to understand what's happening, that's what is happening there. So because it's not fitting, we use this scale 1 to 2, which means this 50 will mean 25, right? And to avoid confusion, I'll just change the dimensions, or to make it even more interesting, I'll just put the reduced ones there. That's 25. This will be 75. This will be 25. We'll follow the same procedure. I want to first mark that 150. So I'll extend this line. This is the point 150 from the center of this circle. Now I need to go 25 below this first circle. Now notice something in drawing. Right? What would happen if I started from this circle? The distances would have changed. Right? I would have still marked the 150, but I would have gone 25 above. So you use your t-square and then place your, this is your t-square, to be something like this ruler. You can place it like that, or even like this, and then put a set square below like that, and then just draw a line going down. For me, I'll find another way of drawing it, but we'll still get the same result. Now we mark our 25. This here will be our center. Just for easier reference, let's call this center O1 and this one O2. At O2, we'll draw our other circle there. So it's a good idea when you draw circles, you show a center line. We already have a vertical line here, we just need the horizontal one. So you use your t-square again. In this case, you just put it on your board and pass through like that. For me, it will take slightly a bit more time, but you should get to the result. Remember, a center line is a short dash and a long dash. After we have this, we can now move a bit more quicker. First thing, we join our centers. Join point O1 and point O2. This is the easiest line tangent you ever draw. Then if you remember, we are going to do this procedure here. Remember, it came from 180 divided by 2. So we need to extend this line. After we extend our line, we stand at O1. We draw a semicircle. You notice we have some points. You can call this point 1 here and point 2. You stand at point 1, open to point 2. We draw an arc like that. Then we stand at point 2, open to point 1, draw an arc like that. You notice the arcs we're from drawing are going to intersect somewhere here. We can call this point 3. Our goal is to draw a line from O1 through point 3. This here is our point of tangency. Remember, I said to have the point of tangency on the other circle, we'll just get this line, transfer it to O2. We don't need to start constructing a 90 again here. How do we slide it? You need set squares like this. I always encourage people to use this longer one when they are sliding. It's easier. You place one of the set squares in line with the line you want to slide, like that. Then you place the other set square, like this. Always ensure that you are very accurate, and then you slide. If you want, you can just lift it. Don't move this other set square, or else the procedure will be wrong. Once you reach O2, you press down the other set square, then you draw your line. So this point here is our point of tangency. What remains is just joining the 2 points of tangency, and we have our tangent. So the blue line is our tangent. I'll just ask you a quick one. If we wanted to draw this at the bottom, what do you think would change in our procedure? Anyone? Feel free. There are no wrong answers. If we wanted to draw this blue line at the bottom, or simply if the tangent was required to be at the bottom, what do you think would have changed in the procedure? Huh? The what? You can raise up your hand so it's easy for me to point at someone. Anyone? Yes. In the upside down part. Eh? Yeah. So I won't go through everything like that. Eh? I will expect that when we go through a procedure like this, the next time you see a question has a tangent at the bottom, it will be able to click and say, oh, I think for me to draw it at the bottom, this semicircle that we used to bisect and have the norm should come where? At the bottom. So let's do, this was external. Let's do another external for